This video is going to serve as a review for the final exam. The format of the final exam will be similar to the midterm that we took, and that it will be a combination of open-ended short essay questions and uh, and code snippets and things like that. So I may ask you to create not full programs, but bits of code. So we did chapters 1 through 6 on the midterm, and we started after the midterm on chapter 7. There's not a lot about chapter 7 that I'm particularly concerned with. Certainly, I will not ask you about enumerations or namespaces. And the string type only comes in handy, and we've used that before. So I wouldn't spend a lot of time on that chapter. Now, chapter 8 is important. That's arrays and strings. So you should be familiar with how to create arrays, either create blank arrays of a certain size and fill them in, or fill them in all at one time with the curly braces. Um, you should be aware that arrays in C++ are not self-regulated, which means that you can't return a length and you can't, or it won't stop you from going to whatever index you want, even if it's out of range. So best practices say that you have to maintain typically a global constant integer for the size of your arrays, and any function that deals with an array, you'll want to send along that size. So the array itself, which makes more sense now than it did when we talked about it, the array, so if you have int a bracket 10, if you would print out a, what you print out's a memory address. So just like pointers are memory addresses, so are arrays. So when we pass arrays to a function, they're going to pass by reference. That's why we need the constant keyword to protect anything that's coming in by reference. So you should be able to loop through an array, print stuff out, um, use the King of the Hill algorithm to do the biggest in the list or in the array or smallest in the array or anything like that. Um, so we're not going to do much with sorting or even searching really on the exam. Just understand that that's a thing. Okay. The parallel arrays we mentioned briefly, it's just the idea of two arrays that are synced up in the same way, and they're just kind of a poor excuse for the two-dimensional arrays. So you should be familiar with what a two-dimensional array is, how to loop through all of the elements by going through first by row, then by column, or the other way around if you want. Know how to declare those and how to manipulate those, print out all the values or whatever. Okay. So structs are important. Again, structs are going to be very important when we go into data structures. So you should understand how to create structs. Remember, structs are kind of like functions, or sorry, kind of like classes, but they're more limited. They have only data, no functions. And structs, everything there is public. So there's no public-private issues, no need for accessors or mutators. Couldn't be because we can't do functions. Okay. But they are very useful to help us organize our data. So you should be able to create those without any trouble. Okay. So remember, structs can be sent to functions either as by reference or by value. Okay, because they're not memory. They're not a memory address the way that an array would be. Okay, they're actually a compound data type. So classes continue on in that vein. So classes are just a struct, but they have functions as well. And because they have functions or methods associated with them, we get into the idea of public and private. And we talked just recently about protected. So for the final exam, you don't have to worry about protected so much, but public and private are important. So the normal way when we develop a class is to make whatever data that we're storing private. And then whatever functions we're going to use, we'll make those public. So typically, if we have a member data name that's a string, we will usually have an accessor like getName, because from outside of the class, we can't directly get to that name value. So we have to use the accessor to return it to us. Um, then we also have the mutators, which are the set name in this case, which allow us to make changes. And one of the reasons by for making the data public, sorry, making it private, is that we can control how it's changed. You're forced to go through a class accessor to change a method if it's private. Okay. Which is an important thing to talk about. Okay. We also talked about constructors, the idea that there's a default constructor which sets everything to some normally zero, normally blank, but we can't guarantee that. But if we want to create a constructor, it has the same name as the class, but no return type. And it can take parameters, and you can overload it, which means you can have multiple versions of it. Okay. So it's important that you know how to create a class. I wouldn't ask for a very complicated one, but I could ask for a simple one that you could create. We talked about the UML diagrams, the class diagrams. Those are the big triangles broken into three sections. It's important that you look over that because people always get those just wrong enough that it's hard for me to give you points on. So you're fairly certain, nothing's certain in life, but you're fairly certain to see a UML diagram that you have to either create or read on the final. Okay. Um, you can define your functions either inside the class or by using the namespace colon. Way to do it, you can define it at below the class, and either way is okay as far as testing purposes go. Okay. So certainly classes are important. They're an important concept. You should know what they're doing, how they're doing, things like that. And again, the information hiding is what's important about that. And then we talk about the difference between a struct and a class, where the class has a lot more functionality. The next thing we talked about was inheritance and composition. This is a way to expand a class that we create or to organize multiple classes. So the idea of inheritance, you go from a base class to a derived class. We typically call that a specialization because you're adding more detail to it. So if you have a vehicle class, it could have a subclass called car or another one called truck. If you have a circle class, it could be further subdivided into circles. A bad example. A shape class could be derived. You could derive a circle from it or a rectangle or whatever you have. Okay. So those are the is a relationship. We saw examples of a person class that gets specialized through inheritance to an employee class. So an employee is a person. And then the composition or aggregation. Oh, and on the inheritance, it's important when you're creating those that the constructor for those classes has to call the superclass constructor. Okay. And we'll skip down, take a little more detail, look at that here in a second. Wanted to give the overview first. So the composition then is the has a relationship. You know, a car has a engine, things like that. So with that, all you're doing really is making one of your member data being an object of some other class type. Okay. Then we talked about pointers. So pointers are memory. They're variables that hold memory addresses. They're specialized variables. So we've done this just recently. So hopefully that'll be fresh in your mind. You should certainly be able to create statements with pointers. You should be able to understand and execute in your head, like what does this line do? You should be able to do those with pointers. Okay. We also talked about the idea of dynamic variables. Those are variables that are created on the fly, not before the program runs. We create dynamic variables with the new keyword, and they typically won't have any variable name. They just have a pointer that we have to dereference in order to get to their values. We'll look at that again in a second. We can also have dynamic arrays that we create same way. And for both of those, anytime you use a new keyword to allocate memory, you have to use the delete keyword in order to free up that memory and avoid a memory leak. So a memory leak is when you have memory that's been allocated that can't be used for anything. Okay. So that's the point through all of that. We also talked about abstract classes. So when you're creating a class, and I think again, the classic example is a shape class. If you're creating a shape class and you want there to be a function called area that every child of shape has, but shape itself doesn't have enough information for that. So if you don't want to define it, but you want to create an obligation. You do that through the pure virtual functions. And that's putting the word virtual in front of the regular program prototype and then adding an equals 0 to it. Any class that has one or more pure virtual functions is called an abstract class, and you cannot make an object of that type. Okay, you have to go with something that inherits from it. Okay. We didn't do any of the stuff with lists, so you can skip the last part of that chapter. And then finally, we skipped all the way forward to recursion and talked a bit about that. Okay. So let's go down to the example on the class section. If it's going to actually let me do this. This is so weird how it sometimes is difficult for me to go where I want to go. There we go. So we get down. It's worth looking over your examples before. I want you to understand what these things mean and be able to use them. We'll be using them fairly quickly. Briefly, I guess, brief examples of things. Okay, so where are we at here? Yeah, so structs, again, we create structs in this way. It's relatively straightforward. The big thing to remember here is just going to be the semicolon after that bracket at the end. Okay, here's an example of what one looks like. There's the name. We can have as many things as we want. And we get to these with the dot notation. Okay, as we will see somewhere in some code. Yes, like new student dot first name. Okay, so again, with structs, no accessors, no mutators. Since they're all public, you can directly change them. Okay, so that's structs. Let's go on down and see some syntax. The book has some fairly decent graphs on helping explain what's going on from a memory point of view. Okay, then we talked about classes, so we're going to talk about class. We mentioned here the private, protected, and public. So private and public, I think, makes sense. The protected, when we have inheritance, becomes an issue. So protected means that the children of a class also have access to any public data that they have. So when we do a public inheritance, it means that the public members of the class are available to the subclasses. If we do a private, then nothing's available, and the private is never available of the subclass to the of the superclasses to the subclasses. Okay. So we talked about this abstract data type, and that confused some people with its definition. So I'm not going to test you on it, but it's more of a theoretical idea that we're going to create this new data type we're going to use. So we implement abstract data types in C++ with classes, but don't worry about that for the exams. Okay. So we also talked about the idea of static. Probably not going to ask you about static on the exam, so I think we can skip that as well. Okay. But we did talk about information hiding, and it's the idea that with classes, we're able to keep certain the data that we have, the member data, we keep it from other functions or even from int main being able to directly access it. So it can't be accessed outside the class, and some of the reasons for doing that. So the class looks very much like a struct at this point, but the difference is we have not only the member data, which we have down here, we also have functions. Okay. So the functions, the prototypes look like this, what they return, and so forth. Okay. Then the book talks, here's the UML diagram. So it's important here that we have the name of the class at the top and the middle. We then have the member data, starting with the type, the name, colon, the type. And the first thing here is a visibility. Minus means it's private. The plus means it's public. Okay. So this is going to be all the member data that we have. In this case, we have the hours, the minutes, the seconds. They're all integers and they're all private. We then have our functions. So we have our accessor. This is using, which we often see, a multi-part accessor that we're able to get the hour, minute, and second all in one accessor rather than having one for each. The same thing. That was the mutator where we're setting those, but the accessor is here, the get time. Okay, it returns all of those, and they're choosing to return them by value, but it doesn't really matter. It is important that mutators are void functions, and I guess there is a reason they're using the passing by reference here. They're passing by reference here because they want to pass all three. If we were doing a singular, like just get hours, the return type would be whatever type the variable was. So it would be an int type. Okay. It's important that the mutators, no, the accessors are always constant. This constant keyword means that we're not going to change anything with this function. Okay. And they're of type void. Again, the syntax doesn't look like this. The constant keyword just gets put in there. The print functions are also constant. Okay. So then we talk about how we can access the functions there. We've done, I think, a good number of examples of these. So hopefully we're we're good on this. Okay, here's an example of a set time function. Again, this has the prototype here that it would be defined outside of the class. So we have the clock type colon colon, and then we're sending in the values, which we're then setting up the values of so the HR is private data of the class. We're in the class so we can see it. The hours is what's being passed in. Okay. Okay, so let's see what else we've got here. It talks about the accessor and mutator functions, what those look like. And they still don't have the singular ones here. Usually the singular one just has a single return type. Okay. So we talk about the constructors. There's a default constructor built in. Sometimes doesn't do what we want to do. We see the constructor here. There are two versions. The default constructor just has no name or no parameter list, where the clock type has the three parameters we're going to set. There's no return type on constructors, and it has the same name as the class. Okay. So there's the constructor that has three, and it goes through and sets those hours. Again, we're checking to make sure that they're between 0 and 24. Okay, actually 0 and 23 because it's less than 24. And then down here, our initial one setting everything to 0. Okay. So we don't really invoke a constructor. The constructor gets invoked when we create an object. So when we say clock type your clock, that's when the constructor is going to be created. Okay. Again, if we have parameters that we're going to have to send. So if we wanted to set it to be 5:12 with 40 seconds, we would say clock type my clock parentheses and then send in those values that go to hours, minutes, and seconds. Okay. So talk about some more stuff there. It's kind of the basic idea. So we can have an array of class objects like anything else. We can have this class, this clock type, arrival time, employees or whatever the imp SOAR is doing here. And then we're setting it equal to that. Okay. So each arrival time EMP from 0 would be a clock type object. Okay. And as we found in doing some of the homework examples, if you're going to do an array of objects, it has to have defined a default constructor. If not, it won't be able to create those variables. Okay, even if it just sets it equal to 0. Okay, we talk about destructors here. They have the same name as the constructor, except they have a tilde in front, and those automatically execute when things go out of scope. We saw that again in the last section, or the next to last thing we did. When you have pointers as member data, you have to use a destructor to free up their memory that gets allocated. Okay. So talk about the information hiding there. Okay, that should be it more or less. Just look at the examples we've done in class. That will give you an idea. Okay. So static members of a class, they're special in that static means it doesn't change its value from time to time when you call when you create different objects. So there's one value for all objects of the same type. Okay. Sometimes people say that static means that it belongs to the class, not to the instance of the class. So the classic example there, if you want to know, if you've got a car class, if you want to keep track of how many cars you've created, then your constructor could update a static variable called count. And that would be the same value for all instances of the class. Okay. And those can come in handy for sure. Okay. So that is that chapter, I think, pretty much covered. Okay. So the next chapter, chapter 11, is where we talk about, once we get there, inheritance. Okay. So inheritance is important. We'll take a look at what that looks like, both in terms of, so here we have just an overall hierarchy. The shape class gets specialized into circle and rectangle. The rectangle gets specialized into a square. Okay. So here's the basic idea. So we have the class name, colon, and then in here, we are almost invariably going to put public or maybe protected. Okay. And then the base class name. So we're saying that this class is, sorry, that this class is derived from that class. And then we add whatever new member data that we're adding. Okay. So I think the real interesting thing here is when we get to the constructor code. Okay, they're doing other things here. Note that as a child class, you can't get to the parent's private data without going through the accessors and mutators. That's what this is showing. Okay, so let's talk about the constructors. Constructors, here we go. Okay, so in this case, we're starting with our, with the class box type, okay, where we have a height equal to 0. So this is the base class. It has height as its value. We're then going to create, or no, that's not correct. They're deriving that. That's the derived class. So we're going to derive that from the rectangle class. We're adding height to it. Okay. So that's what they're saying here. So we're saying the box type, okay, is going to be the derived class. It's going to be derived from, it's a public. They don't have that statement there, which is interesting. They may have put it up here somewhere. Let me see. Let me make sure that we're covering that. Yeah, I don't see the first step. Yeah, I guess it's right here. There we go. It's class box type. It's a public inheritance from rectangle type. So rectangle type is superclass, box type is a subclass. That's what we're doing. Okay, I just went too fast. But when we get to the constructor, what we have to do. So the constructor for box type has to take all the data we're going to need for both it and the superclass. So it takes the length and the width from the rectangle type and the height from the box type. Okay. It's then going to call the constructor of rectangle type, which is the parent class, to let it deal with what it's going to deal with. It only has to deal with what's left over. Okay. So all the data has to be here. All of it has to be dealt with either by the superclass, by calling its constructor, or in this function itself. Okay. So that's an important concept and lots of examples on that. Okay. We didn't do it, but you certainly can create a header file, a .h file, where you put just the function prototypes and then all of the definitions of the function are in a separate file. We didn't mess with that yet. We probably will in data structures, but we're not going to now. So you don't have to worry about that. Okay, we didn't care about that stuff. We do talk about this public, protected, and private, and there's some examples in here. And there certainly could be a question asking to explain public inheritance versus protected inheritance versus private. And remember that the private variables of the superclass, the base class, are never available to the derived classes, but the public ones can be, depending on if it's public, protected, or private. Okay. So that explains that in a little more detail. Okay. Then we get to composition, which is the idea of the has-a relationship. Okay. So with that, when we get down to our private data, that's not showing an example of that. Yeah, that's just a single thing. I guess we're going to do something else with that. Once we have, okay, yeah, this person info, we're using name, which is a object of person type, and bday, which is a object of date type. Okay, so this is the composition. The personal info type is composed of composition, the person, an object of person type, object of date type, and then this personal ID. Okay, so that's what that talks about. These are important concepts here. The idea of encapsulation, that's where we're going to combine data and operations together into one single unit. That's our class. The inheritance is the ability to create new objects from existing ones, which we just covered in this chapter. And then polymorphism, which we haven't talked about yet, is we won't in this class, but it's the ability to use the same expression to denote different operations. Okay. So that's that. Then we went through an exercise here where we're given a paragraph of text. And we're trying to figure out what are the classes and what are the operations. And that's about that. Okay. And I think that gets through that chapter for the most part. Okay. And all that leaves then, yeah, that's chapter 11. We have the chapter 12 talks about pointers. Okay. So again, it's important. We just went through this. So hopefully this is still fresh in your mind. So example here, we have int star p creates a pointer to an integer, but it assigns no, or it allocates no memory. Char star ch creates a pointer to a char, but again, doesn't allocate any memory. Okay. So the star can really be anywhere. We can say either int star p with the star right next to the p, which is the way I tend to do it. Int star space p, that's okay. Int space star space p, that's okay. Okay. So that's not a problem at all. So the other operator we have besides the star is the ampersand or the address of operator. So it returns the address of whatever to its right. So if I said int x, x is an integer, x is a label to some memory address, then we create this int star p. It's a pointer. It doesn't point to anything. It's just a uninitialized pointer. If I say p is equal to ampersand x, now p points to what's in x. Okay, what's at that location. If I want to return the value stored there, I would print out star p or dereference p. Okay, that's going to talk about this next where we dereference that. So again, int x is equal to 25. We're creating this p as a pointer to an integer. We're setting p equal to the address of x. When we print out this, we're printing out what is stored at that location, which should be 25. Okay. Okay, so our classes and structs can have pointers as part of their member data. Okay, that's certainly something that we can do. Okay, so that talks about that. If you want to initialize pointer values to something, so they are defined, you can just say the word null or the word zero if you want. Okay, setting them equal to that, or you can initialize them with the null pointer. Okay. Okay, so then here's the idea of dynamic variables. We create either a new data type here or a new data type with the integers in brackets, which will be an array of variables. Okay, and we have here, for example, for this to work, p has to already be a pointer. We're then creating a new integer, so we're allocating memory that it points to. Okay, and then when we're done, we have to make sure to delete that. If not, we have a memory leak. Okay. If we're deleting something that is an array, we have to do the delete bracket, whatever the name of the variable is. You know, you can always put the brackets in because sometimes you're not sure what's going to be assigned to a pointer. So if you put those brackets in, you're going to be covering your bases in all cases. Okay. As far as the operations that we can do on pointer variables, we can certainly test or we can do assignment. We can set one pointer variable equal to another. Okay. So whatever the address of one would be, that would be the same address stored for the other. We can also use two equal signs to test their equality to see if they're the same. We can do a not equal, as we would expect. Okay. So pointer arithmetic, we're probably not going to talk about really. We'll talk about it in data structures for sure. It can be the source of a lot of problems in our code. Okay, then we talk about dynamic arrays. They work similar to the dynamic variables, except we've added the size element here. And again, as I said in class, pointers in this chapter are kind of dumb. They're not useful at all. They're more complex. But the day is coming in data structures where we need pointers. So that's why we're talking about it with these simple examples. Okay. Okay, so we will not do dynamic two-dimensional arrays. So don't worry about that. Okay. So we always have this problem of shallow copy versus deep copy, and it leads to aliasing. So this just talks about if you set two variables equal to each other, two pointer variables, then if you change one, you've changed the other, and that can be kind of a problem. Okay. So it gives us some different things here. We now have, if we have P, which is a pointer, as one of the member data in our object, okay, then we need to have our destructor, which has a tilde in front, that deletes that P, okay? Since P is a pointer, it may be an array, it may be just a pointer, it doesn't matter, but this kind of way of addressing it with the brackets will take care of it no matter what, okay? So yeah, we mentioned the copy constructor briefly. It used to be you had to create them, but now they're built in, which is a good thing. Okay. I think that's most of what we need from that particular section. So then we talk about the abstract classes. It's weird they throw this in the same chapter, but they did. So the abstract class, again, is a class that has a pure virtual function. So that's the point there. And a pure virtual function looks like this. We have the shape class, which has a draw function, which is a virtual function, and it has the equal 0. So this means that I'm not defining it. There are no brackets. I just end it right there. But this equal 0 makes it a pure virtual, and it means I can't say shape S. But if I create something that derives from shape, it has to have a draw function. That's a void function that takes no parameters. Okay, so that's kind of the idea. And there are some examples there as well. And I think that ends that chapter, if I'm not mistaken. Yeah, because we didn't cover the list at all. So we're not going to worry about those lists. Okay. And then the last thing is just the recursion that we did. And I think since it's more of an issue for data structures, I will not expect you to know anything about recursion for the final exam. Okay. So that was kind of a whirlwind tour of what we've done. Again, not much from chapter 7. We'll start with 8 and we'll move from there. And again, not covering everything. Where's the table of contents? Have I missed it? That doesn't tell us enough. That tells us too much. I'll get there eventually. Yeah, so again, we're starting with arrays for mostly arrays, some string functions, and then we'll talk about structs, we'll talk about classes, we'll talk about how to do inheritance, we'll talk about pointers, virtual functions, abstract classes, not lists, and then we'll do chapter 15. We're not going to cover that on this exam on recursion. So as always, if you have questions, make sure you let me know. We'll have our review in class tomorrow on Thursday at normal class time. So I'm not going to do much except answer questions. So have questions at the ready. If there's something you're confused by, I can do a demo. We can talk about it, whatever you want. Okay. The exam itself is going to be next Tuesday. The afternoon session, the section 2 has their exam at 11, I think, and I'm sure it's the early one. and the morning session has theirs at 1:30, I want to say, but it's on the schedule. We're not varying from the university's final exam schedule. Okay. So any questions before then, just let me know and we'll work it out.